Can you see the screen?
Yes, sir.
Uh, Good evening, everybody, and welcome to course on principles and practices of process equipment and plant design. Currently, we are discussing week 11 NPTEL previous assignments solutions. Myself, Suraj P from Chemical Engineering Department, IIT Kharagpur. So the first question is choose the incorrect statement from the following. Centrifugal pump discharges a continuous flow. Gear pump is suitable for handling high viscous liquid. Centrifugal pump is suitable for handling dilute slurry with concentration less than 20%. Option D, the discharge flow rate of reciprocating pump increase with discharge pressure.
Option D.
Option D.
Yes.
Uh, so for like uh, reciprocating pump is used for obtaining high pressure, and for centrifugal pump is used for obtaining high flow rate. And uh, there is a piston in the reciprocating pump, like it moves backward and forward with the help of a crank to deliver high pressure fluid at low volume. And the flow rate is independent of the discharge pressure. It is dependent only on the stroke length. That stroke length is the uh, length that is moved by the piston, right? How much length is moved by the piston, like number of strokes per minute. Like it is the length that is moved by the piston, that forward and backward. And this gear pump is used for high viscous liquids, and the centrifugal pump can handle up to 20% solid concentration. The next question: a centrifugal pump is used for pumping either water with density 1000 kg per meter cube or mineral oil with density 881 kg per meter cube at a flow rate of 55 meter cube per hour. The head developed by the pump is dash in both the cases, and the power required by the pump is dash in case of pumping water when combined with mineral oil. So here they are uh, same pump. They are pumping two fluids. One is water with high density, and the other is mineral oil with density of less than water. So there are the flow rate is same. They are asking how the head and the power required by the pump changes, like whether the uh, head developed by water will be higher or mineral oil will be higher, and the power required for pumping water will be higher or uh, mineral oil will be higher.
Hair developed by water is high as compared to oil.
No, actually that like for a particular centrifugal pump, the uh, head developed is independent of the density. Only it is dependent on the three things, like impeller diameter, like impeller diameter, then frequency, and the flow rate is independent of uh, fluid property. Head developed by a pump is independent of fluid property. like a similar question was asked in the I think here it was asked in exam. A similar question is asked last year's exam, like
Okay.
how the like head is varying, like but the head develop is independent of the fluid, like therefore for water and mineral oil the head developed is same. Can you see what I am writing here? Hello.
Hello.
What I am writing, is it visible, like what I am writing here?
Yes, sir. Yes, sir.
Like it depend only on the diameter of impeller, then frequency is given by n, frequency of the impeller rotation speed, then flow rate of the fluid. It is independent of density, so head developed will be same, but the power will be different. Like the expression for power required by a pump is given by, like this is the expression for power required by a pump. Here the density term is coming, like here this is head, delta H is head, rho is density, g is acceleration due to gravity, and q is the flow rate. So here the power is directly proportional to density. So for which fluid the power will be higher, for water or mineral oil? Can you tell for which fluid will the power required will be higher?
Oh, water for water.
Okay. So the correct answer will be this one, option B. The head developed will be equal in both cases, and uh, power required will be higher in case of water. So next one, fill in the blanks with suitable option from the following. In a centrifugal pump, flow rate Q is proportional to here rotational RPM is given. RPM is how the flow rate, head developed, and power depend on the rotation per minute of the impeller. Like this we can get from affinity laws of pump. This is obtained from affinity law of pump. So
Option B.
option B, flow rate. Yes. Uh, so let us see. Consider the case where a pump is used for delivering a fluid from tank 1. This is tank 1. This is tank 2. Here the pressure in the tank 1 is P1, pressure in tank 2 is P2, and the difference in level is given by delta Z. So there are two types of head. One is the system head and one is the pump head. System head is due to like this automatic pressure from this tank, like tank 1 to tank 2. One automatic pressure will be there due to head. So the flow rate Q will be increasing when we increase the flow rate, then the system head will increase. Like it is increasing with square of velocity. So if you plot a figure with flow rate versus head, the pump head will be decreasing and the system head will be increasing. When the flow rate is 0, the system head is given by the difference between these two, like P2 minus P1 by rho g plus delta z. So this is the pump head and this is the system head. So usually the design head will be where the point where the pump head and the system head coincide. So this is the design head, where the efficiency of the pump will be maximum. So if you plot a efficiency versus flow rate curve, then here the efficiency will be maximum at a point of convergence of pump head and system head. So this will be chosen as the design head. And it should be noted that we should never operate the pump at its vapor pressure. So the pressure in the pump should never fall below the vapor pressure of liquid at that operating conditions, at that operating temperature. So if it happens, then cavitation can cause damage of the pump. And other factors affect main factors affecting the performance of pump are one is the head developed, that we have discussed how it varies. Head developed by a pump first increase and then decrease with flow rate. So here we can see a more rapid decrease in the head with flow rate, with increase in the flow rate. Next one is the power required. This is the pump head. So the pump head decreases with the flow rate. Here but the system head increases with the flow rate. So the power required will be increasing with flow rate. More power will be required by the pump to deliver more flow rate. This power is given in kilowatt. Then next one is the efficiency of the pump. Like this efficiency first increase and after reaching a point it will decrease, and this is the efficiency given by eta. The efficiency first increase and then decrease, and the point where it is maximum is known as like that break efficiency point. uh, so so this is the variation of head first increase and then decrease, then the power required always increases, then the efficiency increase and decrease, and uh, its maximum at that beat efficiency point, BEP. And the efficiency is given by the power transferred to the pump by the shaft pair, that is power delivered by the shaft. Efficiency is given by power transferred to liquid divided by the shaft power. and and the power required by the pump we have already discussed. Like P is given by delta H into density into flow rate into acceleration due to gravity. And by considering the like how we can get the affinity law, like this, it is obtained by solving that dimensionless number, that Buckingham, using that Buckingham theorem we can first check how many independent variables are there, then what all are the factors. By considering that we can uh, solve that Buckingham uh, non-dimensional equation and check how the flow rate, power and head uh, change with flow rate, how the head power and uh, how the head flow rate and power change with the frequency and diameter of the pump, and it is given by affinity law. So like if we keep the impeller diameter as constant, there are two cases. One is for a specific pump with constant impeller diameter. For that case, the flow rate will be like if Q2 is the flow rate of condition 2 and Q1 is the flow rate of condition 1, then it will be varying as N2 by N1. N2 and N1 are the impeller frequency in condition 2 and condition 1. Similarly, the head will be changing as H2 by H1 equal to N2 by N1 square. And the power will be changing as P2 by P1 equal to N2 by N1 cube. Similarly, the next case will be if we keep the impeller speed as constant. If the impeller speed is given by n, if we keep the impeller speed as constant, then all this thing will be same, except that the ratio will be diameter of second by diameter of first. Q2 by Q1 will be equal to D2 by D1. D2 and D1 are the diameter at condition 2 and condition 1. Similarly, the head will be H2 by H1. So these are the affinity law. So next question, what is the purpose of knockout port before a compressor? Option A, to store compressed gas. Uh, Question is, what is the purpose of knockout port before a compressor? Option A is to store the compressed gas. Option B, to reduce flow rate of incoming gas stream. Option C, to remove unwanted particles and liquid droplets from the incoming stream. Option C, to increase pressure inside a compressor. So can you tell what will be the use of knockout port in a before a compressor?
Option C.
Option C. Okay. Like the usually knockout port is placed before a compressor to remove unwanted particles from incoming stream. Like if some unwanted particles like water droplets enter the feed, it can be separated using a knockout port. Like it is a vertical drum. If the feed contains some liquid droplets, there will be a demystifier pad with which can separate any liquid droplets which will be entrained with the gas. So this is the knockout port. So if some liquid droplets is carried with the gas, the compressor can be protected with the help of knockout port. Like it is usually arranged in vertical. It can be placed in horizontal also, but the efficiency will be lower here, lower in case of horizontal. Like with the help of gravity, the liquid will be falling falling bottom, and it can be removed in continuous interval of time. So there should be a design velocity of the feed, which then only that there will be a minimum entrainment of the liquid along with the gas. So this gas will be used as a feed for compressor. So next question, purpose of interstage coolers in a multi-stage compressor is to: option A, reduce the power requirement, reduce the cylinder size, reduce cost of metallurgy for the piston cylinders. Option D, all of the above. So can you tell in multi-stage compressor why the interstage coolers are used?
All of the above.
All of the above. Then uh, can you tell how the usage of cooler will help to reduce the cost of material of construction of piston and cylinder? uh, like just before that, what will be the condition? It will be if we do interstage cooling, then whether the process will be adiabatic or isothermal. Like if we use coolers, interstage cooler.
Isothermal.
Isothermal, okay. So the actually the multi-stage compression will be a polytropic process, uh, and if you draw a P versus V diagram, this will be with a graph for polytropic, and this will be for isothermal. So if this is the compressor one, which is at low pressure, and we cool it with using cooling water, and if we feed it to compressor 2, which is given by C2, like if we use this type of system, then nearly isothermal process we are able to get, like this is obtained from thermodynamics book. So if we can nearly obtain a isothermal process, and the work required will be minimum in that case, uh, when the process is isothermal. So if the temperature here is T1, here also will be nearly T1, but a slight variation will be there. So after each compression in a multi-stage compressor, the pressure increase with stage. So in the coming stage the pressure will be higher. So in each case the outlet temperature will be increased. So this uh, this will lead to higher power consumption in the next stage, because if the outlet temperature increase, the volume of the uh, gas to be handled in the next stage will be also be increased. Volume to be handled in the next stage will be increased, then the work required in the next stage will also be increasing. So if we cool it in between these two stages, then we can attain isothermal condition, nearly isothermal condition, where the power required will be minimum. So this will help to reduce the cylinder size. So if we can handle the same volume in next stage also, and the power input in the next compressor, uh, also it protects the parts of the compressor in the next stage, because uh, thereby we can thereby we can choose low cost, low material of construction piston and cylinders. So we need to note that the work required will be minimum in case of isothermal. And this graph also we need to remember. So the answer for this one will be option D, as it reduce the power requirement, reduce the size in the next stage, and reduce the total material of construction of piston and cylinder. So, next one, choose the correct statement about selecting a process vessel. Option A, horizontal vessels are preferred for forming liquids. Option B, vertical vessels are best choice for limited floor area. Option C, horizontal vessels are preferred over vertical vessel for low liquid to uh, vapor ratio, low vapor to liquid ratio. So what is the correct answer?
Option D.
Option B. Option B or
Yes, sir.
option B is correct, but
D.
option D. Okay, okay.
All of the above.
So so this is the reason why mainly separators are vertical, because like in after the reaction, the m- more amount of vapor will be generated in the in after the reaction, more amount of vapor will be generated, which will be condensed. Still some vapor will be uh, uh, remaining in the remaining after condensation, under uncondensed vapors. So for removing that, we need to use vertical vessel which can handle high vapor to liquid ratio, but the horizontal vessel can handle only low vapor to liquid ratio. So mainly the separators are vertical in vertical vessels. And here the horizontal vessel in extraction, after extraction we'll get some foaming liquids. So after the stages of extraction, we find mainly horizontal vessels. The next question, consider the following two statement. Statement 1, a bracket or leg support are for horizontal vessels. Statement 2, skirt support are for vertical vessels. Choose the correct statement from the following. Both the statement 1 and 2 are true. Both the statement 1 and 2 are false. Statement 1 is false but 2 is true. Statement 1 is true and 2 is false. So this one will be the
Option C.
option C. 1 is false. Okay. So this one will be the leg support. It will be used for vertical vessel, not for horizontal vessel. But the skirt support will be used for. This is the skirt support. It will be used for vertical vessel. So option C is the correct answer. The leg or bracket will be used for vertical vessel, not for horizontal vessel. Next one, match column 1 containing type of nozzle with column 2 with the suitable example. In column 1, process nozzle is given, utility connection nozzle is given, instrumentation nozzle, then nozzle for safety equipment fitting. In column 2, some examples are given, so please match it and tell what will be the correct answer.
Option B.
Option B. So process nozzle is used for like entry of reboiler vapor to distillation column. Yes, correct. Like other than this, that process nozzle is used for other purpose also, like entry and withdrawal also they are used. Like both entry and withdrawal of product. Of product to columns, distillation columns. Then the utility nozzle, so one will be D. Then the utility nozzle will be used for compressed air. The compressed air is a type of utility for pressure testing and for other purpose, like it can be used for transportation of steam, then plant water and other things. Other than this, we can use it for steam, then plant water. Then instrumentation nozzle, like for it can be used in thermowels, nozzle for fitting thermowel. And this is thermowel is used for temperature measurement, and the thermocouple will be dipped in the thermowel. And this nozzle for safety equipment fitting, this is used for overpressure relief valve, like pressure safety valve. So can you tell like what is how the temperature safety valve is working? Like pressure safety valve is working with if the system pressure is greater than the load that is loaded on the safety valve, it will be ruptured. So how the temperature safety valve will be working? So in temperature safety valve, if the temperature increase, the liquid expand and the vapor that is generated by the expanding liquid will be used for indicating the it will be acting against the load applied by the safety valve. One load will be applied on the safety valve. So the in both cases pressure is acting on the load that is applied on safety valve, and it can be there are two types of safety valve. One is it will be ruptured permanently and we need to replenish it after that rupture. And the second one is it will be just opened when that set pressure is reached, and when the system pressure is relieved, it will be closed. So the correct answer for this one is option B. Next one, consider the following two statements. A thermocouple is suitable for measuring both high and low temperature. RTD gives a linear response. Resistant temperature detector gives linear response. Choose the correct option from the following. Both statement 1 and 2 are false. Both 1 and 2 are true. 1 is false and 2 is true. 1 is true but 2 is false. So can you tell what will be the answer? Which one will better, thermocouple or RTD? Which one will be better? Actually, the here both the statements are true. That thermocouple is used for measuring high and low temperature, and RTD gives a linear response. But the stability and accuracy are more in case of RTD, and the like the stability, accuracy, and repeatability are higher than thermocouple, and and it is working on the principle like there will be a platinum wire which will be when it is heated up it will be linearly expanding. So there will be a resistor also to measure that. So higher the temperature, when the temperature increase, higher the temperature, higher will be the resistance. And the common range will be, it can read from minus 200 degrees Celsius to 850 degrees Celsius. But it is expensive than thermocouple because platinum wire is used, and it gives a linear response because temperature varies linearly with resistance. So here both the statements are true, so correct answer will be option B. Next one, choose the incorrect statement among the following. An open loop will contain only measurement and indication of its process variable. A feedback control loop will always incorporate a controller. Option C, error is the difference between set point and the measured variable. Option D, set point is the desired value of the output signal from a controller. So can you tell what is the incorrect option written here?
Option B.
Option B. Like, option B it is correct because there will be a always a controller always a controller will be there in case of feedback control loop. Will always incorporate a controller. So this will be the set point. This is the measured variable. This will be the controller. Then this is the process. This is the measuring device. In feedback controller always a control will be there, and the option B is correct option, not correct option, it is a correct statement. Then like here the error is given in a feedback controller. Error is given by difference between the set point and measured value. So here we will be getting the error, which is set point minus measured value. This is the error that will be getting. It will be sent to the controller. Controller will be using PID controller and other things. They will be reducing the error and checking again. They will be checking with the measuring device whether the error is reduced or not, and it will be delivering to the output. But here the statement 3, you can see that set point is desired value of output signal from a controller. But actually the set point is the value that is input to the controller, not output. So here this is an incorrect statement. Option D is incorrect statement. uh, but in case of here the option A is also correct, because on in an open loop only measurement and indication will be there, where there will not be any uh, feedback in that case of open loop. So here the correct answer is option D. So if you do you have any doubts regarding this?
Sir,
Yes.
sir, in the live interactive session conducted by Professor Ray and another ma'am, some of the questions are not answered, sir. So some of the question asked in the question are particularly meant for live interactive session.
Okay.
So next time if you get time, please do that one, sir.
Okay, I will ask him to do it.
Sorry.
I will ask Racer to do that. Hello.
Okay, sir.
Like, eh, like one more live session they are going to conduct.
Okay, sir.
I think that will be informed uh, in your portal.
Okay, sure, sir.
Like how many questions do you have? Any query? If you have more queries, you can post it in discussion forum again. Other than this, if you have some other queries,
Yes, sir.
like one more live session they are going to conduct. So this, along with the unanswered question, some more questions.
Yes, sir. While writing the questions in that form, we find difficulties, sir, because we can write only in a single sentence. It's not again expanding. Suppose I cannot go to the next line. Another thing is that I cannot impart any kind of pictures in that because I have certain doubt with the distillation part. In that, it's kind of an option like question where too many number of arrangement of too many distillation column in series. So I cannot put those kind of questions in that particular form. So where can I put such kind of questions? Question actually involving certain kind of pictures like that.
Okay, so in that case, you need to directly mail to that process, or else,
Professor Ray.
Professor Racer,
Okay.
or else in the coming one more in the next week, one more live section will be coming.
Okay.
So in that you can post it, but there you can't upload in Word file. I think it is Excel sheet.
Okay.
So you need to directly mail him, um, because in
Okay. Okay, sir. Otherwise, if I put those questions in discussion forum, it will be directed to the Professor Ray. Is there any possibility?
Yes, yes. Like only he is only answering. Professor Reza and Gargi ma'am both are answering.
Okay, okay.
But you are telling that you cannot upload the image.
Yeah,
So I think you need to mail him only.
okay.
Okay, have you
Thank you.
registered? Have you registered for exam? Uh,
Sorry, sir.
have you registered for the exam?
No, sir. I am asking. I am learning only, not register for the exam.
Okay, okay. Oh, okay then. If you have any queries, you can mail.
Okay, okay, sir.
Okay, then. Thank you for listening.